Okay, so we have applied the force in this surface right here in our previous lecture. Now let's we can see the force right here. It is showing the amount of force we applied, 11,000 Newton. So let's now rename this force. To rename it, click pause, then again click on this, and we will name this tensile strength. TENSILE tensile strength. Okay, so we have named the force. Now after external loads advisor, we have a new menu right here. This is called connections advisor. So if we drop down this bar right here, we will see different options. The first one is contact set, then the other one is component contact, then contact visualization plot is spring, pin, bolt, bearing. So these are mainly used when we are running analysis on assembly parts, on not assembly parts, on a full assembly. So if we click on contact set, for example, let's click on contact set. As you can see here, it's first showing that what type of contact do we want to use. If we want to use manually select contact sets, then it is tick mark on it. It has tick mark on it, and then the next one is automatically find contact sets. If we click on this will automatically find contacts. So as I said before, these are for assemblies only. When there are 2, 3, 4 or more than 2 components in a design, and we want to give relations between two surfaces while they are colliding or contacting, then these type of contact advisor are used. If we click on manually select contact on this, we can see here that this is the type of contact we want to apply. If we click down this, there are bonded contact, allow penetration, sink fit or virtual or etc. Type of contacts right here. And here if we want to define contact with a edge and a surface, we can select the edge in this box, and the surface with which we want to define the contact will need to be selected in here. Then we have the friction right here. If we click on this, we can select the amount of friction, how much friction we want to allow to be there between the surfaces. We have other options like gap or clearance. We can also determine the we can also allow the contact gap between two surfaces. So this is for assemblies. We will talk about it in our later lectures. So there are other options like springs. If we component contact or contact visualization plot, these are also for advanced purposes and assembly purposes. Let's see them. Let's get familiarized with them. So this is for components. In the first one, we just selected surfaces or edges. In this one, we can select components. We can select, suppose there are 3 part files in assembly, we can select the component 1 and component 2 and apply a relation between them by using this contact component option. And the third one is contact visualization plot. If you click on this, it will show us this type of image. That means it allows us to see what is the contact type we have applied on a certain assembly or a certain components. So this will allow us to visualize the contact. Let's close it. Then in the contact advisor, the other options are spring, pin, bolt, bearing, etc. So for example, we are designing a suspension. So for suspension, we must have design some spring. So how much load the suspension will take, for that reason we must assign the spring a maximum amount of load or force. If we click on this, we can see that there are different types of springs right here. So we can select any one we want. like this, and here we have other options on that. If we select on, let's talk about string first. So here we have flat parallel faces spring, or we can use concentric spring, like we want to adjust, give relation between two concentric springs, or we can select two springs in different directions. So, and here we can select the surfaces of the spring and apply load right here. How much load we want to apply on each surfaces of the spring, and run the analysis also, and how many tension or what will be the total load of the spring will undergo. We can select it right here. So we will talk about this portion later when we will have more complex geometry to run the analysis. So this is all about contact advisor. I hope this is clear to you. So far we have learned applied material, simulation evaluator, then we have learned about fixer advisor, then we have learned about external loads advisor, then we have learned about connection advisor. Now we will create mesh. So as far from the previous lectures, we have learned about FEA or finite element analysis, and we know that Solidworks run on this type of SolidWorks. The backbone of Solidworks is finite element analysis. So by meshing, we will divide this geometry into finite elements, and then here in this bar we can see the tensile strength. In the bracket is showing that per item, the number of force will be applied in per item. So we haven't created the items yet. By clicking on mesh, and by creating mesh, we will be creating the items here. We will divide this geometry into finite number of elements, and we will apply this amount of load in each elements to analyze the final result. So let's there are two options to create mesh on this model right here. We can give the command from here, or we can drag down this menu and we can click on create mesh, or we can click on this, right click on this, and then we can create mesh. So let's just click on create mesh. So the mesh option has been opened, as you can see here. So the first option is mesh density. So SolidWorks simulation is suggesting us medium mesh density as the default that SolidWorks simulation will use for meshing this model. Mesh density directly affects the accuracy of results. The smaller the elements, the lower the discretization error, but the longer the meshing and solution times. If we drag this to the fine area, the density of mesh will be greater, and the result will be more finer, and the result will be more accurate. And if we drag it to the coarse area, the density of the mesh will be less, and the result will be less accurate. So SolidWorks actually does give us and the average mesh density, but we will drag it to the fine area to get more accurate answer. Now if we click on mesh parameter, here we can see it is selected on standard mesh, but we will select curvature based mesh. Curvature based mesh algorithm generates a mesh with a variable element size that allows the accurate resolution of small features in geometry. So if we select standard mesh, it will be the default option from SolidWorks, that the result will not be that accurate. To avoid that, we are selecting curvature based mesh. If we drag down later, we can see here are some options, like the first one is about unit. We can, as we are analyzing this whole model in CGS, we will keep this centimeter. Then the next option is we have the maximum. This is the maximum element size. So if the mesh is created, the maximum element size of this of the mesh will be 1.64 centimeter. If we want to increase it or decrease it, we can increase or decrease it, and the minimum amount of and the minimum element size will be 1.64, the same. We can decrease it to create the mesh more accurate. Let's decrease it to 4.49. Then the next one is minimum number of elements in a circle. This is the minimum number of elements. That means we are how many elements we want to create in a certain circle. If the circle has 1 centimeter dia, then how much element we want to create in a circle. If we want to increase or decrease the number right here. And the next option is here for element growth size. So the maximum, the ratio, it is the ratio between the maximum element and the minimum element right here. So these are the mesh parameters. We have talked about mesh parameters here. Now if you click on advanced, we can see here Jacobian points are 16 points. We can increase or decrease the Jacobian points as if we want. We will talk about Jacobian points more in our later lectures. So let's drag it to the finer area. Now here is another option, which is mesh quality. So if we click on it, we can see we have two options right here, the high quality and the draft quality. So in high quality we can see our model has been selected, but in draft quality it has been null. So the main difference between draft quality and mesh quality is the draft quality mesh uses first order elements and the high quality mesh uses second order elements. As we discussed in our previous lectures, we have I think we have learned about first order elements and second order elements. So this is what high quality and draft quality does. So let's just cross it. So we will create mesh and we will make it to the finer area. We will go to mesh parameter. We will select curvature mesh. Then we will drag down this number right here, 0.49, and then we will click OK. So as you can see, the mesh has been created. It took some time and the mesh is now fully created. The whole object has been divided into the smaller parts. As you can see, these are the areas where the mesh diameter are higher, and these are the area where mesh diameter is less. So the mesh has been created in our model. So in this we can, if we want, we can deselect, we can show and hide the mesh. To do this, we will right click on this mesh right here and we will click on hide mesh. This is how we can hide our mesh, and then we will again click on this and we will click show mesh. So as you can see, the mesh has been created. So far what we have learned about applying material. We have learned about simulation evaluator. We have learned about fixer advisor, and we have learned about external load advisor, then connector advisor. Then we have learned about creating the mesh. So the next option will be run this study. So let's just run this study. If we run this study, what Solidworks does, Solidworks will analyze the result. The result is here. The applied force is 11,000 Newton per item. So Solidworks will analyze the result and show us let's see what it shows us. Click on and run this study. So the study is been running now. As you can see, it will take some time. So the study has been completed. So as you can see, the analysis has been completed. So we will learn about creating the result and reading the result, how we will read the result in our next lectures. Till that time, thank you guys, see you soon.